Hey, hi, this is Sabita Sunkara. So, today's question: how do you optimize a query that joins multiple tables? So, this is one of the most common question and asked in SQL interviews for experienced developers. Imagine your query joins 10 different tables and takes nearly 2 minutes to execute. The interviewer asks, how would you optimize this query? So then let's understand the approach step by step. So the scenario is, suppose we have a query that joins multiple tables such as a customers, orders, order details, products, categories, employees, suppliers, payments and regions. The query is returning the correct data, but it takes around 2 minutes to complete. Now, as an experienced SQL developer, don't immediately start creating indexes. First, understand the requirement and analyze the query. The interviewer wants to know how you approach performance tuning, not just the final solution. So, before optimizing the query, we need to understand how SQL Server executes it. So the SQL Server optimize first analyzes the query and creates an execution plan. So based on statistics, indexes and estimated cost, it decides which table should be accessed first, then which join order is most efficient, then after which join algorithm should be used. So SQL Server can choose one of three join types. One is nested loop join, another one is hash match join, then merge join. So nested loop join best for smaller data sets where indexes are available. Hash match join suitable for large data sets when indexes are missing or large amounts of data need to be processed. Then the merge join best when both inputs are already sorted and appropriate indexes exist. Remember, we don't choose the join type manually in most cases. The SQL optimizer selects the low cost execution plan. So there are many reasons why multi-table joins become slow. Here missing indexes, if join columns are not indexed, SQL Server performs full table scan, increasing input or output and execution time. So select the star, returning all columns increases memory usage, network traffic and discretes. We already know this. Always return only the columns required by the business. So too many rows, joining millions of rows without filtering early forces SQL Server to process unnecessary data. So apply filters as early as possible. So non-searchable conditions, avoid applying functions on indexed columns. So for example, where if order date equal to 2025. So here where how we have to write the query, where order date greater than or equal to some date you can mention, and order date less than the limitation of the date time. Okay, that means for example 2025 0121 and the less than 2026 0101, like that. So this allows SQL Server to perform an index seek. Then what wrong join conditions? Then incorrect joins can create duplicate rows or Cartesian products, significantly increasing execution time. So always verify join conditions carefully. Okay. Then outdated statistics. The optimizer depends on statistics to estimate row counts. So outdated statistics may lead to poor execution plans. Then data type mismatch. So joining on int column with a varchar column causes implicit conversion, preventing index uses. So ensure both join columns have compatible data types. Then also unnecessary joins. avoiding joining tables that are not required for the final output. Every extra join adds processing overhead. Then the technique of the optimization. Now let's discuss. Create index on columns used in join, where, order by, and group by clauses. Composite indexes are often useful when multiple columns are used together. What here? Reduce the number of rows before joining large tables. This is known as a predicate pushdown. Remove unnecessary joins whenever possible. The fewer table SQL Server processes, the faster the query. Then avoid using select start. That means retrieve only the columns required by the application. Then update statistics help SQL Server choose better execution plans. After that, you whenever possible use inner join instead of outer join. Avoid cross join unless absolutely necessary. Okay. Then the right saggable queries, that is avoid functions on indexed columns and use search arguments that allow SQL Server to use indexes efficiently. Then the execution plan. Always review the actual execution plan. So focus on expensive operators like table scan, sort, hash match, then keep lookup and missing indexes recommendations. These often indicate where performance improvements are needed. Then the real-time tips. Whenever I optimize a multiple table query, I follow this checklist. First one, understand the business requirement. Then review the query carefully. Analyze the actual execution plan to identify bottlenecks. Then check whether proper index exists on join and filter columns. Verify that statistics are up to date. Then apply filters as early as possible. Also, we need to remove unnecessary joins and return only the required columns. Then after, finally compare execution time before and after optimization to ensure the changes actually improve performance. Then, suppose if the interviewer asks, how do you optimize a query that joins multiple tables? Then how we have to answer? I first understand the business requirement and analyze the actual execution plan. I identified expensive operators. So verify indexes on joins and filter columns. After that, update statistics if needed. Then apply filter early, remove unnecessary joins. Also avoid select star and ensure the query is saggable. After making changes, I compare execution metrics like CPU time, logical reads, and execution time to validate the improvements. So this answer demonstrates a structured troubleshooting approach and reflects the practical experience expected from a senior SQL developer. So optimizing multi-table queries is not about applying a single technique. It's about understanding how SQL Server processes data, analyzing the execution plan, reducing unnecessary work, and helping the optimizer choosing the most efficient execution path. Thanks for watching. Subscribe for more advanced SQL interview questions and real-world SQL Server performance tuning concepts. Thank you.